do the clock hour. So h is equal to negative 16 t squared plus 2717. I've got two variables, and this is where you need to keep track of things. I have two variables. I have t, and then t is time, and the units in time is going to be in seconds. The second variable in my formula is h, and h is height, and it's going to be in feet. If I were going to do a graph of this guy, I would model my x-axis is going to be in t, and this is going to be in seconds. My y-axis is h, and this is going to be labeled in feet, x and y. That means I put in time, I get out height. I put in height, I get out time. So if I were to draw a picture, and I will make our building a little bit more square, or rectangular actually, this is 2717 feet to this point right here. And then you have this person standing on the top of the building, then dropping a penny to the ground. And by the way, and this is ground right here. And there goes the penny, down, 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 and eventually hits the ground. And it's not thrown. And how do I know it's not thrown? Anytime you have a problem that looks like this, when you have an object or a projectile being thrown or dropped, if it's thrown, like you're going to see in the next problem, there's going to be a T in there. There's going to be a something T. And what that tells you is what it's going to be that the speed that thing started out. You'll always see a negative 16. And a negative 16, negative means it's going down. 16 ends up being the acceleration due to gravity. If I were on the moon, this wouldn't be a negative 16. It would be something else, because gravity on the moon is different than gravity on Earth. But gravity on Earth, you're always going to see the negative 16 in the front. And you notice it says at the beginning of time, it was 2717 feet from the ground. That's this constant. That's how high was it when it started. Now, what did I want to know? How many seconds? So I want to find t. Will it take for the penny to reach the ground? Now remember, I have two variables. I have a formula which says h equals negative 16 t squared plus 2717. I'm either going to put in t and get out h, or put in h and get out t. So that means I've got two variables. I have t and I have h. In order to find one of the two, I have to know one of them. If I had three variables, in order to find one of the three, I would need two of them. So that says I have to have one of these two. It says how many seconds. I want to find what time is. I don't know what time is. That tells me I know what h is. And I look at it and I said, it didn't give me a number for h, but it did. It says reach the ground. What is the height of the penny from the ground when it is on the ground? 0. So that means ground level, h equals 0. So they've given me an h value. The h value is 0 because it's 0 feet off the ground when it's on the ground. So that means that 0 equals negative 16 t squared plus 2717. This is 9 too, so I'm going to add 16 to both sides. So 16t squared equals 2717. I can use the square root property on this, but I'm going to divide both sides by 16 first. So the t squared equals, now I need to take 2717, divide that by 16, and you can either say, it ends up being 169.8125. You could say it's approximately 170. You could say it's approximately 169.8. So 169.8, it doesn't tell me how many decimal places to take it to. If I wanted real accuracy, I would take it out to 169.8125. And then, since this is the one we use the square root property, take the square root of both sides. And don't forget the plus or minus. So this is t squared equals 169.8, or t equals plus or minus, now the square root of 169.8 is 13.03 approximately. So now I've gone to an approximation of 13.03. And somebody asked me this in the 8 o'clock hour, what's this strange little symbol here? Well, I can do approximately. You're used to seeing the little squiggles. Another way of writing it is the equal with the dot over top of it. So either one of those can be approximately. And lots of times I already have my equal in there, so it's equal. It's better just to put the dot over top for approximately. Yes? Yeah. And the reason for that is this. We're saying t equals 13.03 seconds, right? Or t equals minus 13.03 seconds. What really in our world doesn't make any sense? The negative. And so time, even though sometimes we would like it to be, never negative. So I can say it takes 13.3 seconds for the penny to reach the ground.